Hello everybody. Today I can interpret the meaning of the components of an exponential equation using A equals principal parentheses 1 plus or minus the rate to the power of time. Let's hear our song. Let's go to Schlansky.com, YouTube, still at 300. I always think I'm going to lose some because, once you listen to it a little bit, you're like, I don't want to hear this guy's voice anymore. Playlists, Common Core Geometry, Algebra 2 songs. And again, we're just listening to the first verse of this for now. And we're going to get into the later verses later. Principal parentheses 1 plus or minus the rate to the power of time by 3 by 100. Principal parentheses 1 plus or minus the rate to the power of time by 3 by 100, yo. Yeah. So, now what we're going to do, instead of building an exponential equation, I'm going to give you an exponential equation, and you need to understand what the different components mean. So, when I see this equation right here, I have, let's actually be able to write, let's go purple. I have A equals 3600, 1.025 to the power of t. And I know that my formula is principal parentheses 1 plus or minus the rate to the power of time. So let's take a look at what's going on here. The 3600 is your principal or initial or starting value. Whatever's in front of the parentheses, that's your initial, your principal, your starting amount. It's your y-intercepts. If you're talking about the graph, that's what that value always represents. Now, what's inside the parentheses, let's do a different color for that, is the rate, kinda. It's 1 plus or minus the rate. But obviously, you're pulling the rate from that. So the first question is it 1 plus the rate, or is it 1 minus the rate? So to answer that, is this number more than 1 or less than 1? If it's more than 1, then it's plus. If it's less than 1, then it's minus. So from here, what am I adding to the 1? Well, in this case, and you're really best off being able to do this mentally. I mean, we can do it procedurally, but just through my experience, if you're able to do this mentally, it just makes a lot more sense. When you're doing it procedurally, you can get a little lost, and you're less likely to remember the procedure. This is 1 plus what? Well, this is 1 plus 0.025, which means the rate is 0.025 as a decimal, which means as a percent, if I were to multiply that by 100, it would be 2.5%. So before I even look at the specifics of this problem, I know that the initial or starting amount is 3,600, and I know that it's increasing by 2.5%. That's understanding and interpreting the components of an exponential equation. So now let's go through each choice. It's asking which is false, but I'm going to go through all 4, and I'm going to determine if I agree or disagree. So the function represents the value of a bank account after t years. The initial investment was 3,600. So the initial is the principal, is what's outside of the parentheses. So yes, I agree that the initial investment was 3,600. The annual interest rate of the bank account is 2.5%. Yes, I agree with that. 0.025 is being added to 1 inside the parentheses, which makes it an interest rate of 2.5%. The value of the account after 5 years is 4,073.07. Well, I'm going to replace t with 5 and see if it gives me 4,073.07. So I'm going to do 3,600, 1.025 to the power of 5. I'm going to pull up my calculator. 3600, 1.025 to the power of 5. 4073.07 looks good. It will take 12 years for the value of the account to double. All right, so let's replace the t with 12 now and see if it doubles. Now, by double, since the initial value is 3600, the doubling value would be 3600 times 2, which is 7200. Is that 7200? No, that's much less. So, no, it will take more than that. Choice 4 is false. This is really an important lesson as far as understanding the components, not just in this course. SAT-wise, they ask a lot of questions where you have to understand the components of the exponential equation. So for that reason as well, this is a really important lesson. Number 2, the function v of t equals, let's just write that a little bit bigger. Let's do a new color. I'm getting so bored with these same colors. Whenever I get bored, I always pick orange. Orange is simple. I don't know if you noticed, but I trained myself to say orange instead of orange because I'm actively trying to get rid of my Long Island accent because it sounds horrible. See, I said horrible, not horrible. I'm succeeding. All right, anyway, the function v of t equals blah, blah, blah represents the value of a stock investment after t years. So before I even look at the choices, I'm going to just break this down on my own. So we're talking about the value of a stock. This is my initial or principal value. So I'm guessing. I'm not guessing. I'm concluding. Oh, that word wasn't coming to me. That 10,000 would be the initial investment of the stock. That's how much I bought into the stock initially. This is telling me, since it's more than 1, it's telling me that the stock is increasing. What is it increasing by? Well, what am I adding to 1? I'm adding 0.112, which as a percent would be 11.2%. So I'm just looking at this, and I know that I put $10,000 into this stock, and it is growing 11.2% each year, based on my understanding of the components of the exponential function. So I'm going to go through each choice now. The stock is increasing by 11.2% each year. Yes. The value of the stock after 3 years is 13,750.37. Well, let's find out. Let's do V of 3. V of 3 equals 10,000, 1.112 to the power of 3. 10,000, 1.112 to the power of 3. It's 13,750.37. Yes. This one is true. The value of the stock increased by 1245.44 between year 1 and 2. So I'm going to have to find the value after year 1. Now I'm going to have to find the value after year 2. So I can just kind of copy and paste this with a 1. And then I can copy and paste this with a 2. So to see how much it increased, I would just subtract the value from year 2 and the value from year 1. So V1 is 11,120. V2 is 12,365, whatever. And then when I subtract them, 12,365 minus 11,120, I get 1245.44. So yes, that one works out. The initial stock investment was 11,120. No, the initial stock investment was 10,000. I think if you substituted 1, yeah, we have it right here. When you substituted 1 in, you got 11,120, but that's not the initial investment. That's how much I have after 1 year. The initial is whatever is in front of the parentheses, the y-intercept, the principal, the initial, the starting amount. That's what's in front of the parentheses. So that one is not true. So choice 4 is your answer. I guess I made this problem last year because I just bought a Subaru Ascent last year. I want you to try this one on your, oh no, let's start it together. So let's look at the function. The reason I want us to go over this one together is because, well, you'll see. This thing just froze. Let's see if it unfreezes. Okay, I'm unfrozen. Sorry about that. I'm back. All right, so we have V of t equals 40,000.887 to the power of t. So without even looking at the choices, we're talking about the value of a car after t years. So this, in general, is my starting or initial or principal amount. So I'm going to conclude that the car cost, I bought the car for $40,000. This 0.887 is the rate. Well, is it more than 1 or is it less than 1? It's less than 1, which means that it is decreasing in value. It's 1 minus the rate. Now, what percent is it decreasing? Well, 1 minus what is 0.887? That's the question. Or think of it this way. If you're maintaining 88.7%, what are you losing? The answer would be 11.3%, 0.113. And if you can't do that mentally, then just go to your calculator and type in 1 minus 0.887. But what you have to determine is what is being added or subtracted from 1. It's easier when it's added, because when you're adding something to 1, it's literally just this value. When you're subtracting it from 1, you have to do the subtraction, which is just, not as simple. And again, if you can't do it mentally, then just do 1 minus 0.887 like we just did in the calculator, and that'll give me that. So now that we talked about that, I want you to pause, and I want you to try number 3 on your own, and then unpause, and I will go over it. Okay, now that you tried number 3 on your own, we talked about the components already, but let's kind of go through it. The initial value was 40,000. Well, the initial value is what's in front of the parentheses. Yes. The value of the car is decreasing by 11.3% each year. Yes. Again, because what's inside the parentheses is less than 1, to find the rate, I need to determine what I'm subtracting from 1 to get that. It gave me 0.113. As a percent, we multiply that by 100, it's 11.3%. The car is worth $15,324 after 5 years. So we'll do V of 5. I got 21,962, so nope, that does not look good. 21, that is not 15,324. It decreased 3,556 from years 2 to 3. So I got to find V of 2 and V of 3 and subtract those. So V of 2 and V of 3. V of 2 is 31,470. V of 3 is 27,914. This problem is depressing me. I'm just seeing the value of my car diminish. I'm just losing thousands and thousands of dollars of doing this problem. So this is a little depressing. Let's see, how much money did I lose between years 2 and 3? Well, if I subtract that, And that $3,556.20. I'm upset now. I just lost 3,000 something dollars doing a math problem. So yes, that one is true. The answer is choice 3. So it's about understanding what the components mean. This is your principal or initial value. This is 1 plus or 1 minus the rate. If it's more than 1, then it's growth, and you have to ask yourself, what am I adding to 1 to get that? And if it's less than 1, then it's decay, and you have to say, what am I subtracting from 1 to get that? And generally, we think in percent, so once we have that, we would multiply it by 100 to get it as a percent. All right. Number 4. There's a twist on the rest of them. There's a twist on 4, 5, and 6. So here's the twist. In order for this to work, my standard form, I'll put it up here. My standard form is principal parentheses 1 plus or minus the rate to the power of time. I need just a t in the exponent. I don't have just a t here. And this is what we did in the previous lesson. We learned how to get it as just having a t in the exponent. So I'm just going to write it here so there's more space to deal with it. If I want there to just be a t, I need to absorb whatever's in the exponent into the parentheses. So right now there's a 1/12. So I'm going to absorb that 1/12 power into the parentheses. So I'm going to do 1/2 to the power of 1/12. And I get 0.94387. Let's just write that all. 0.94387 to the power of t. So we did that in the previous lesson. We absorbed whatever was in the exponent into the parentheses to get just t. Now that I have just t, I can use this to find the rate. If I didn't have it as just t, it's really kind of meaningless to me because I don't really know what the rate is unless it's just t. So now that I have that, why don't you pause and try to do number 4 on your own from here. When you're done, unpause and I'll go over it. Okay, now that you tried number 4 on your own, let's go through it. Every hour, the amount of pain, and I'm guessing T is hours here? Yes. Every hour, the amount of pain reliever remaining is cut in half. No, it is not cut in half. It is decreasing by about 5 or 6%. Because this is 1 minus, if it's maintaining 94%, it's losing 5 to 6%, not 50%. That's not correct. If you looked at the original and you saw that 1/2, yeah, it looks like the rate is 1/2, but again, you need just the t in the exponent. In 12 hours, there's no pain reliever remaining in the body. So let's substitute t for 12 and see if I get 0. I'm pretty confident that is not going to be the case. In fact, I'm pretty confident it never fully leaves your body. But let's take a look. I'm not going to use my science knowledge as a math teacher right now. I'm just going to do what I got to do. Again, I don't like to round until the end of the problem, so I'm just going to copy and paste that whole thing. However, if you wrote it out to 5 decimal places, it really shouldn't be an issue. Is that 0? No. It's 1/10. It got cut in half, but there's definitely not none remaining. In 24 hours, there's no pain reliever remaining in the body. So let's copy and paste this and change it to 24. Is that going to be 0? Nope. 55. So A of 24 equals 55. So that's not true. Choice 4, in 12 hours. Well, we already did 12 hours. There's 110 milligrams remaining. Yes, that's true. Choice 4 is the answer. So the twist for this problem and the rest of the problems, you need, in order for this whole interpreting thing to work, you need there to be just t in the exponent. So if there's something with it, you need to absorb it into the parentheses, which we did in the previous lesson. That lesson was called equivalent exponential expressions. I want you to take a look at number 6. The problem with number 6 is the fact that the exponent is not just t. So I want you to try number 6 on your own right now. Your first step is going to be to get just t in the exponent. Once you have that, you're going to go through each choice and see which one you agree with and which ones you don't. So please pause, try number 6 on your own, and then unpause. Okay, now that you did number 6 on your own, again, my first issue, I need just t. So, since I don't have just t, I am going to absorb whatever was in that exponent into the parentheses. So, it's going to be 1.15 to the 3.2 power to the t. I'm going to go to my calculator. I'm going to do 1.15 to the power of 3.2. And I get 1.56 and a bunch of stuff after. Let's write a little bit more than that out. 1.56398 to the power of t. So now that I have just t in the exponent, I'm prepared. I know that this is my initial or starting value. I know that this is my rate. So we're talking about the value of an investment account after t years. The account is increasing by approximately 15% each year. No, this is not 1 plus 0.15. This is 1 plus 0.56. It's increasing by about 56% each year, which is choice 2. Choice 3, I always have to go through all 4 choices. There will be $1,216.80 in the account after 2 years. So let's do V of 2. And I mean, you can substitute, when you're substituting in, you can substitute into the original one. You can sub into this one, or excuse me, this one, you'll get the same answer. But having it in this form is going to help me more with the rate. So I'm putting in 2 here, 500, copy this thing to the power of 2, and I get 1223.03. That is close, but it is not close enough. Whenever I'm that close, I'm like, well, is there a rounding error? But no, it's not it. It will take 3.68 years for the account to double. So let's do V of 3.68 equals 500, 1.56398 to the 3.68. For it to double, I got to end up with 1,000. So I'm putting in 3.68. I get 2592. So it doubled way before that. So that's not true. So choice 2 is your answer. So your classwork/homework is to finish this. Again, to interpret exponential functions, whatever's in front of the parentheses is your principal or initial or starting value. whatever's inside the parentheses is 1 plus or minus the rate. If it's more than 1, then it's 1 plus the rate. If it's less than 1, then it's 1 minus the rate. If it's 1 plus the rate, if it's more than 1, you have to ask yourself, well, 1 plus what gives me 1.025? 0.025. Turn that into a percent, multiply by 100. When it's decay, if it's less than 1, you have to say 1 minus what gives me 0.887. If you can't do that in your head, then you can just type that into your calculator. You get 0.113. And again, to make that into a percent, multiply by 100. If you don't have just t in your equation, you need to get it as just t by absorbing whatever's in the exponent into the parentheses, which we did in the equivalent exponential expressions lesson. I hope everybody enjoyed this. I hope everybody has a great day, and you learn more math. Bye.